So complete dominance is what we've been doing for the previous part of the period and all day yesterday. It means that it's the law of dominance. That dominant allele will mask the recessive allele. The example that we've had, that we've seen in the P's of Mendel, were the flower color. So that big A would equal red. Little a equals white. And so that if you have big A or big A or big A little a, they're both going to be red. And the only time you can show white is if you have little a, little a. That is complete dominance, where the homozygous dominant and the heterozygous are both dominant, and they show you red, and the recessive will be white. 2 phenotypes, that's it. You've got 2 different phenotypes, either you're dominant or you're recessive. And so what is incomplete dominance? Incomplete dominance is where there isn't a true dominant trait. So if you don't have a true dominant trait, what happens to the heterozygous? Well, the heterozygous condition is a separate phenotype. Neither allele, the big or the little, is dominant over the other. And so what you'll see is 3 different phenotypes. You'll have a phenotype for the homozygous dominant. You'll have a phenotype for the recessive. And then when you mix the 2 together, the 2 alleles, the heterozygous, you're going to have a 3rd phenotype. Think about painting. You have red, you have white. When you mix them together, it is pink. Red and white paint mixed together is pink. And so we have a new let statement because you need to show that there's a 3rd phenotype. So big A, we still call it homozygous dominant because it refers to the big letter, will be red. Little a is white. And then when we put big A with little a, you mix. It's literally a blending of the traits. So you're blending red with white, and that will be pink. So now your let statement looks very different, right? You don't just have one letter. And this is how I recommend. Some teachers still teach it big A equals red, little a equals white. But then I think students get confused when you put big A and little a together. They expect it to be red, not an incomplete dominance. And that's why I like, did I just say Dominic? Incomplete dominance. That's why I like doing a separate let statement to show each of the new phenotypes. Now you have 3 phenotypes. And what it actually looks like is this. You have red flowers, you have white flowers. When you mate the red and white together, they are pink. What if I mated 2 pinks together? So let's try that out. What is the genotype of pink? Big A, little a. Oh, go back up. Sorry, it's not letting me write. Imagine a little a here. Go away. It's not letting me write it. Big A, little a. This is big A, little a. Little a, little a. Now think about your ratios. What is my phenotypic ratio now? Jacqueline. Very good. Because you can't just combine big A, little a, and big A, little a, because those are different phenotypes now. You have to make sure that you know big A, that's when you look back at your let statement, that is red. Big A, little a, that is pink. And little a is white. My genotypic ratio is still the same, because those are the letters. That hasn't changed at all. But you need to make sure that the phenotypes are different. Jacqueline.
How do you know when it's incomplete dominance?
You will be told, so the question was, how will you know when it's incomplete dominance? You will be told in the story problem one of 2 things. 1, I will tell you it's incomplete dominance, or 2, I will tell you that there's 3 phenotypes. Okay. If you see 3 phenotypes in your word problem, you automatically know that it's incomplete dominant or codominant, and that's what we're going to do in 10 seconds. Do you need this on the screen still? Do I need to freeze it? Nope? Okay. So the last thing is codominance. Codominance is very, 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 very similar to incomplete dominance. The thing that's different is both traits are being expressed. So instead of the blending, the red and white blended together to make pink, you would actually see red and white. So that wouldn't blend together, you would see both traits. So neither allele is dominant over the other, nor do they blend together. They each get expressed. Anybody go ride horses and know anything about horses? Maybe. Do you or no? Yeah? So roan horses are actually a codominant trait. That's the best known example. And what it is that it's a red horse that mated with red-haired horse, mated with a white-haired horse, and all of the offspring, they weren't pink. They were both red and white hairs. And so you see a picture right here that you could see the red hairs and you could see the white hairs on the belly and the red hairs on the leg. And so what this is, to show you a roan, so your let statement is still the same that you would have with the incomplete. Big R is red. Little r equals white. Big R is roan. That's what they called it. They didn't call it red and white. They called it roan horses. So the only way that you could get a roan horse is if you mate a red with a white. So if you do a big R with a little r, you're going to get all roan horses. If you mate a red with a roan, a white with a roan, or a roan with the roan, any one of those, you're still going to be able to get the roan, because a roan is big R, little r. Any questions about incomplete or codominant? The difference between the two, so there's still 3 phenotypes. The difference between the two is that incomplete blends the two, the dominant, the recessive to make that middle ground, a blend of it, and the codominant is each of them you'll have your dominant, your recessive, and then the heterozygous will express both traits. There's no blending, it expresses both. Adam.
So will you tell us when it's codominant as well?
Yes. Or I might say the heterozygous shows both traits. Okay, yes.
Okay, so what about like with dogs with different breeds when they breed like different breeds